Okay, so this is it. The difference of two squared. If you have an expression with two terms, if you have an expression with two terms, a and b, so a and b can be variables, like we said, it can be numbers, it could be an expression. If it's exactly the same and you have a minus b times, in brackets, times a plus b, the way you expand that, you don't have to do the long method of doing the four things. It's simply the first one squared minus the second one squared. A minus b, a plus b is a squared minus b squared. Yes, no, the reason for that is, if they're both plus, it'll be a plus b squared, which means a squared plus 2ab plus b squared. So that's what we looked at yesterday. Okay? The sign has to be different between the two terms. That's why it's called a difference of two squared. Okay, so you got a minus b, a plus b has to be in this form. A and b have to be the same in both sets, and the sign between them has to be different. If that's the case, it becomes a squared minus b squared. And the reason for that is this, that when you do the long way, you expand it out. The middle two terms, they cancel out. You subtract one from the other, and it cancels out. Are there any questions? Alright, so it's in this form. When you have an expression in this form, a minus b, a plus b, it goes to a squared minus b squared. Alright? So I'll let you write this down and then I'm going to do some examples. So yesterday we looked at the perfect square, okay, where you have a binomial squared, something in brackets, something plus something, something minus something squared. Today we have two binomials, but the only difference is that one has a plus, one has a minus. And when you have that, expansion is very easy. A squared minus b squared. So if we go up here, so the first one is, and so the trick with this is to start being able to recognize the difference of two squared. Okay, that the rule in a sense of expansion is very simple. But, and later we're going to learn to factorize expressions like this, come back to this. But the first thing is to recognize that it's a difference of two squares. Yes. Oh, yeah, in a second. Yes, yes. Oh, well, you can do the second one. Can you tell me what the first one is? X squared minus, sure it's 3. 9. Yeah, so remember, it's the second one squared. So that's the quick expansion to say, well, x squared, we square the first one, and a minus, we square the second one. Yes? Yes, pretty much. Yeah, because this term, minus 3 times plus 3 is minus 9. Yeah, the other two terms cancel out. Nina, you want to tell us the next one? Good. So 4 and 4, so square the 4 minus square the t, it's t squared. (16 minus t squared). Alright, so you're just recognizing that it's a difference of 2 squared. 2x plus 5, 2x minus 5. So this is also a difference of 2 squares. The two terms are exactly the same, they just have a different sign between them. So you need to do this though. This is where you have to do 2x squared minus 5 squared. Okay, if I can write it like this. So Adam, what's it going to be? Yeah. So what's it going to be? What happens when I have something in brackets all squared? What do I have to do with each part? Yeah, that's right. I have to square each part. So what's the first term going to be? Yeah, 4x squared. Alright, and that's an important part. That when we have the first term, we've got to square the whole thing. So you've got to square the 2, which becomes 4, and you have to square the x, which becomes x squared. So 4x squared. Andy, what's the second term going to be? Well, 5 squared is what? 25. So that's all it is. So minus 25. Okay? So you get x squared, 4x squared, sorry, minus 25. Alright? Think questions? No? Yes, sure. Yes. And I'm going to give you some other examples. So you just hang tight for a moment. Although I do appreciate your enthusiasm. Yes. Oh, so that's what I'm saying. You take the first term, which is 2x, and just to show that you square the whole thing, I'll put a bracket around it and square it. Just to illustrate the point. Yeah, so I'm just saying that you have to square the 2 and the x. That's all I'm showing. Well, just it's 5 squared. So the second term in my binomial is 5, so I have to square that as well. 5 squared is 25. This one? Oh, so what I'm saying is that the quick way to expand something like this is by saying that you take the first one, you square it, take the second one, square it, it's minus between. So if you expanded it the long way, you'd see that the other term would cancel. Alright, last example for this one. Alright, the last one, 4s minus 3t, 4s plus 3t. Not good, exactly. 16s squared, and it's always going to be minus 9t squared. Alright? So it's a nice, simple way. We're talking about the difference of two squared. Okay. Alright, so we're talking about that. Now the other thing that I wanted to do today was going over these three things we've done. Okay, binomial expansion, perfect square, and the difference of 2 square, putting it all together to simplify algebraic expressions using all these tools that we've done. Okay, so we're going to go through a few examples where we put it all together and see whether we can simplify it. Yes, okay. Okay, so if we have a look, example, simplify the following expressions. So we've got a few, can I go to there, alright? So we've got the first one, x plus 2, x plus 3, plus x squared plus 2, x plus 2 all squared. Alright, so we need to take it, each part separately, expand it, and then simplify. Okay? So we need to do that. So the first part we're going to do this part. X plus 2, x plus 3. Alright, so we need to expand it using our, this is not a perfect square, this is not a difference of 2 squares, so we simply have to do the method of multiplying each one by the other.
X squared plus 6?
This one?
Yeah.
Well, if it's a perfect square, it's just something like this. You just have a binomial and you have a square. Okay? So you know that that's the way you do it. Or you have the same one multiplied together. So this one is, well, x squared and 6 is correct. You're just missing one term. Alright, so you've got x and x, x and 3, 2 and x, 2 and 3. Josh, how do you expand this one? Good. Yeah. Plus 6. Good. Alright, so we've done that one. Now, how do I expand this perfect square, Nina? Yeah. Good. Good. Very good. So we've got all our terms, and now we can simplify. Simplify this, please. Okay. Selecting like terms. We're selecting like terms. Good. 2x squared plus good plus 9x. Good. Excellent. And then if we wanted to, we could go ahead and factorize that, but we're not going to do that just yet. That's coming in a few lessons time. So that's as simple as it can be. So we've condensed, simplified this expression, expanded and simplified to this. Alright? Any questions? I was just recognizing each one, how to expand it, and then combining like terms to simplify. Next one. So this one here is a perfect square. 2x minus 1 all squared minus x plus 2, x minus 2. First part. Show me. How do you expand this first one? Remember, you've got to square the whole thing. The x squared is right. We've got 2x all squared. So what's going to be? 4x squared. Good. 4x squared. Right. Next term. We can give you the next term in this, right? X squared. Take away 4 something else. Remember, we multiply the two terms and then double it. Multiplying the two terms. Multiply minus 1 with 2x. Minus 4x. Right, and then the last term, what's the last term going to be? Right? This one. This one. Oh, I'll get to that in a moment. We'll run in a second. I think I'll show you the way that I think. Maybe you can think about this one, maybe. Okay, so minus 4x. What's the last term in this? What do we have to do to expand this perfect square, Josh? Well, no, it'd be plus 1 because we're squaring this, and so it's plus 1. Right, minus, what I'm going to do is put brackets around it.
With that 1, do you just double the 1?
You don't double it. Let's put it plus.
Oh, you square the 1.
Alright, so I'll go over perfect squares again. Listen carefully. You square the first one. So you do 2x all squared, which is 4x squared. The second term, you multiply the two together, and then you double it. Minus 1 times 2x is minus 2x, times 2 is minus 4x. And then you square the second term, which is minus 1 squared, which is plus 1.
So 2x squared equals 2x
all squared.
All squared
is 4x squared. Because you have to square the 2 and the x. You multiply the two together, minus 1 times 2x, and then you double it. Yeah? Okay, now this one. What is this one? What expression is this? We've just looked at it. How do we expand this one? What is it then? Good. X squared minus 2 squared, which is 4. So now we have to expand this out. So you see here, as Cooper's pointed out, we've got this minus sign here. So if I expand this bracket, what I'm going to get is 4x squared minus 4x plus 1. I'm going to leave it the same. This becomes minus x squared, and then it's minus 1 times minus 4 plus 4. Now, Rob, can you simplify this expression? Collecting like terms. Good. 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 Plus 5. Excellent. Alright, so that's what we end up with. When we combine like terms and simplify, expand, that's what it becomes. Okay? So that's each step, we're taking step by step. Now watch this one. Remember that when we multiply, when you have a negative sign in front of a set of brackets, all that means is you change each thing inside the brackets, you switch its sign. So this is positive x squared, so it becomes minus x squared. This is minus 4, so it becomes plus 4. Yes, ma'am. Oh, yeah, 3. Okay, question 3. Let's have a look. Can you expand the first two sets of brackets, please, Rodney? Good. Oh, what about the other terms? Is this a difference of 2 squared? That's all right. So we've got the two terms. What else do we need to do? We have to do this one. Good. That's 2x, yeah. And then good. That's good. On an S, I'm going to put bracket again. What's this expression here, Alexis? Difference of 2 squared, so can you expand it? Yeah, 4x squared minus 1. Good. Excellent. So now we have to simplify it. And so I'm going to do another line. I'll do 6x squared minus 2 plus 2x minus 6x. Now remember, this negative sign changes each one's sign. So it's minus 4x squared plus 1. Then, can you collect the like terms here? Good, 2x squared. Oh yeah, minus 1. Excellent, minus 4x. And we just rewrite that in order of power. So we do 2x squared minus 4x minus 1 is what we end up. Alright, so we're using these three things: binomial expansion, difference of 2 squares, perfect squares. Alright, so go over it, particularly perfect squares. I think a few of you are having a bit of trouble with. So go over it, take your time, make sure you're doing it. These two exercises, which is actually 3. Yes?
I'm not trying to be smart, but like, when do you use these in real life?
In real life? Okay,
Yeah,
let me...
When you know how you don't find an answer,